This is homework 2 for CSC577 recommender systems. In this homework, we have 3 parts. The first part is to implement a global bias recommender and perform grid search to find the best parameters based on the mean average error. So to implement this recommender algorithm, first of all, I initiated 2 variables. One is for the regularization term for the user, and the second one is the regularization term for the item. And then these 2 values are going to read the value from the configuration files, which are from these 2 variables, and they are reg.userBias.regularization, and the other one is .itemBias.regularization. And this recommender algorithm is actually altered from the biased matrix factorization recommender implemented in LibReg. So you will see commented code here say biased MF implementation, and under this section is the original implementation using using the overall bias regularization. But in this case, instead of using the bias regularization, we break it down into user bias and item bias. So in the user bias matrix here, we actually need to change the bias regularization into the user regularization as well as for the item. And last thing that we changed here is the predict function. Originally, in the predict function, we have the user bias, item bias, and a global mean, plus the product of the user matrix and item matrix. But in this case, we are building a global bias recommender, as stated here. Global bias recommender, we are only using the user bias and item bias to make predictions. Therefore, here as shown here, we only use the user bias plus item bias plus the global mean to predict the certain item for a certain user. And here's an example of the global bias recommender running. You can see that to run 300 iterations is a lot faster. The next part of this section is to perform grid search to find the best parameters. And in this case, the lowest MAE I could find was 0.611. And the configuration was under 300 iterations, and the user bias and item bias both set to 0.0005, while the gradient descent learning rate is set to be at 0.001. The second part of this assignment is to tune the parameters of an implemented recommender algorithm in LibReg. In this part, I chose to tune the parameters for biased matrix factorization recommender. In this case, we only have 3 parameters to tune. The first one is the bias regularization, and the second parameter is the number of iterations, while the third item is the gradient descent learning rate. And after perform the manual research, I found that the best configuration to produce the lowest MAE is with 100 iterations, while the gradient descent learning rate is at 0.001, and the regularization bias is at it's really small, which is 0.000001. Third part of this assignment is to run 5-fold cross-validation on the tuned algorithms from part 1 and part 2 and compare the MAE. So here I have calculated the MAE for the global biased recommender, which the mean average error after 5-fold cross-validation is around 0.6176. And for biased matrix factorization, after running 5-fold cross-validation, we got an average of MAE at around 0.6209.